Welcome to module number 2. In module 2, we're going to be doing footprinting and reconnaissance. It's our first real hacking module. Let's get started. Let's have a look at what we're going to be doing in module 2. We're going to start module 2 with a look at some of the basic concepts in footprinting and reconnaissance. We're going to move from there into some of the search algorithms and methodologies, and then look at internet services. We're going to look at networking sites. We're going to look at who is with footprinting. So these are many different areas that we can use to pull information about various networks, organizations, etc. And then we're going to look at DNS and email. And email's in learning objective number 7. And then we're going to move from there with social engineering. Now, we have an entire module on social engineering, so we won't spend as much time there as we will in the module. But we also have automated footprinting, and we're going to visit this idea of using AI in several different areas in the module. And we're going to look at countermeasures. All right, so one item that I'd like to talk a little bit about with countermeasures is that the majority of the focus of this class is on offensive, meaning attacking. So when we get to countermeasures, periodically it'll be an overview focusing on the areas that are most important for the exam and the areas that are most important for real life. So let's go ahead and move over into our first learning objective. Let's have a look at footprinting concepts. When we look at footprinting concepts, what are we trying to do with footprinting? What we're doing is we're getting the lay of the land. It's kind of like if you were in the medieval times and you wanted to attack a castle. What you would do is take some of your troops and sneak around and look at the walls, look at the gates, look at the moat, see if there really are crocodiles in there or not. Maybe sneak into the city if you can. Find out what types of defenses they have. Do they have crossbows? Do they have trebuchets? See how prepared they are for an attack. Is there a big stash of gold somewhere? What is there? What is going to be involved with attacking this castle? Now, fast forward several centuries, and we're going to be doing that with apps. We're going to be doing that with networks. We're going to be doing that with users. We're going to be doing that with resources. So we have two major types of reconnaissance, passive and active. A lot of times you'll hear passive referred to as OSINT, open source information gathering. Have you heard of a little network called the internet? Yep, all over the internet is information about almost anything that you can imagine, and it's open source. We can go gather that information. And we don't have to interact with the resource, so it is passive. And then with active, what we're going to be doing is directly contacting that resource. Sometimes I call this tickling a port, right? We're going to actually send something into that port, send something into that service, and elicit a response from that port, elicit a response from the service, elicit a response from a person. There are many different ways to actively footprint. All right, so let's look at some information that we would get from footprinting. So we get information about the organization. So is it a corporation? Is it a business? Is it an individual? Where is it? How was it founded? Where is it listed? Is it on the NASDAQ? Is it on the stock exchange? We get all that information about the organization itself. Then we get information about the network. Where is that organization in terms of network? What IP address blocks are they using? Maybe we can get some whois or some DNS information. We go a little bit further and we get information about the operating system. What type of operating systems are they running? Maybe the iOSs that they're running on their edge network devices. Maybe we get information of where their web servers are located. So a bit of a story. There was an organization, it is a large private school, And I, many decades ago, wanted to get a job there. And I decided that for the interview, I wanted to have a lot of information about the organization. So the day before the interview, it had just occurred to me to do this. I was going to show how skilled I was. And back then I didn't really know a lot about hacking. So I decided to find their website, and I found their website, and I started to scan their website for components and information about the company. But after a short period of time, I realized, oh, their website is co-located. It's not even hosted in their organization. So I went there without that really cool information that I wanted to have, but I still got the job. So I was able to find out where they were located, like you see here, the location of their web servers, but it didn't give me enough information about the organization. All right, this is the overview of what we're going to be looking at for this module. You can see it on the slide. So if you look at how it's broken down, we start with a division between passive and active. We move through several different types of footprinting, starting at the top here where we have search engines, all the way to the bottom where we have AI. And then each of those splits off into other areas. This is your guide slide. So if you look in your courseware, you'll see where this is located, and you can use this if you want to go back and look to see a certain type of footprinting and where it comes from. Okay, so here in learning objective number 2, we're going to start with an area that I'm sure that you've dealt with for quite a while, and that is footprinting through search engines. So with search engines, we have quite a lot of variety of information that we can find. One of the areas that I have really enjoyed when Google first came out of this is some of the Google hacking techniques you could do, specifically with Google search operators. Have you ever used Google search operators? If your answer is no, then why don't you open up a tab right now in a browser and go to google.com and do a simple search like this. Let's say CEH, and then put a space there, footprinting, and then put a space after that and type in site : and then give it Microsoft.com as a site and hit enter. And what you'll see is it only searches for those terms in the Microsoft.com web app. So it's a way to limit the search. We can look inside URLs. We can look inside web pages. We can look inside cached content. So this is very important. And we can apply this to AI searches. Let's go have a look at this on the board. So we're going to look at our first SGPT mention in this course. And so what we have is we have it powered by the ChatGPT API in the background. And what we'll see is we use various methods to pull information out of ChatGPT through that API. So use file type search. If you look at the quotes, use file type search operator to obtain PDF files. So that's very important because what the LLM, the large language model, will do is look specifically for PDF files. On the target website, ecouncil.org, oh, wait a minute, you're going to be hacking our website? I guess so. And store the result in the recon1.txt file. So that's what we're having it do. It's not only going to obtain the PDF, but it's going to store the information it finds on a text file on this drive. So another thing that we'll see is the _ chat. So the _ chat means it's going to spawn a chat prompt for the LLM. There are many other ways that we'll talk about throughout the class that you can use SGPT besides using the _ chat parameter. But either way, what it does in the end is it makes use of those tools to eventually output all of this to a .txt file. The really cool thing is that you can use the same technique to output to an HTML page, to output to a comma delimited file or a space delimited file or whatever you want. There's just a huge array of methodologies that we can use AI to deliver results and information to us. All right, so one of my favorite websites. This is the GHDB. If you want to have a look at this, open up a web tab and type in GHDB in your search and hit enter. And the first entry will bring you to the Google Hacking Database. And what page you will get to on the Google Hacking Database, you'll see the word dorks, D-O-R-K-S, Google Dorks. And the reason that we talked about those operators in one of the previous slides is because Google Dorks make use of those operators in order to do specific searches. What we'll see as we get deeper into the course, we could find Amazon S3 buckets using those operators. We can find cameras. In fact, in Google Dorks, in the search area at the upper right-hand corner, you can type in webcam and hit enter. And then you'll find a variety of Google Dorks that will find a webcam for you. Be careful, because some of these are open webcams in people's living rooms or in some business in another country, or sometimes I've found them in like an alley or looking out on a street or whatever. It's insane what you can find with Google Dorks. Also with the Google Hacking Database, where there are components of operating systems or apps where there are vulnerabilities, it'll list those too in the exploit section, but we'll get to that a lot later. Okay, so we have Google Dorks, we have the Google Hacking Database, and I want to introduce to you another app, and this is one of the apps you should get to know. So periodically, I'm going to tell you about a tool that you need to be familiar with. And this is one of them called Shodan. And if you have the opportunity, it would be great if you create a very low-level free account on Shodan so you can use it on your own desktop. Now, you can use it without an account, but you can only do one page of searching, and that actually might be good enough for you. But with Shodan, you can find devices, you can find resources, you can search by a specific type of port or protocol, you can search for a specific type of device. It's great for IoT and OT, and you can find devices all over the world. Next thing we look at is looking at search engines. And here we see some of the basic search engines, Google, Bing, Yahoo, Ask, AOL, Baidu, and my favorite, DuckDuckGo. I use DuckDuckGo for my primary search engine. So you can use Google Dorks. And by the way, those Google Dorks or the actual operators work on Google, they work on Bing, and they work on DuckDuckGo and on many other search services. The cool thing about Google, though, is it respects those operators the best, meaning that if I did a search in Google and I put quotes for 2 different or 3 different terms and I put quotes around it, I'll have page after page after page that respects those quotes before it breaks out into the individual terms. DuckDuckGo and Bing will break out into individual terms a lot quicker. So Google respects those a lot better, which is very nice. But I want to show you something. What I did is I made use of a large language model, or LLM, to see what I can pull out of a search. Let's have a look at this one. So what I did is, let me go to the board here and read this for you. What I told Google to do is I said, give me an nmap command to determine if there's a firewall in the way. So that's what I told it to do. And this is just at the regular Google prompt. And then what happened is it gave me an AI overview. The AI overviews that Google produces change over time as they modify Gemini, so yours may not look like this. But it told me to perform an ACK scan. And by the way, that's what I was looking for, an ACK scan to identify the firewall. You can use a SA. And again, that's another thing I was looking for. And it did it. I thought, hey, that's really cool. It did a very good job. Another one that I did is I went to Microsoft Bing and I said, give me an nmap command to determine if there's a firewall in the way. And yes, it gives me search results, but let's look at the other side over here. And what you'll see is it actually went to Copilot, and it did not give me the ACK scan for Nmap. Instead, it gave me something that was less useful. All right, well, that's not too bad. So the next thing I did is I went to Grok. This is from x.com, what used to be Twitter. And there's a really nice AI there. It's going to be growing a lot soon. And I gave it the same thing. Give me an Nmap command to determine if there's a firewall in the way. And it went right away to the correct Nmap command. So I can easily use a large language model, use AI to pull out information that I might have had to do in the past using a Google search operator. Lastly, I gave this command to Perplexity. And if you look at what Perplexity did, Perplexity was able to give me a good answer also with the -SA parameter that you see right here. So Perplexity also did a very good job. I was happy to see that. Perplexity is also pretty free. A lot of these are free. You can try these things out on. And just ask it for what you want. And if you don't get the right answer, refine your query and you might get what you're looking for. So another thing I tried with the search operators is I just went to Google. Let's have a look at what I tried over here. And in this case, you know how I was telling you before that you can get all kinds of crazy webcams? Well, I thought maybe I could get that from Google using its LLM. And I said, find for me a list of websites that have the term webcam where in the URL. Remember that little operator in URL colon? Well, it failed. It just gave me a standard search of webcam. But then I tried that again with in URL with the search operator, webcam, and I got a much better refined list. And so what I kind of got from this is that it's much better to build your own queries using search operators or Google Dorks, right now at least, than it is to use a search engine. All right, let's go into this next learning objective, number 3, and we're going to demonstrate footprinting through internet research services. Okay, so what type of research services? Well, if you look over here, we see TLDs, top-level domains. So when you look at the structure of DNS, we have the root domain. There are 13 root servers around the world, and there's a .dot domain. And then under that, we have our top-level domains, which are .net, .org, .whatever. So these are the ones you're familiar with, .gov. And so what we're going to do then is drill down and see if we can find subdomains from those top-level domains. And so what we see here is we're using Netcraft. Netcraft is a very nice tool for that. And you'll be using things like this in the upcoming lab, but Netcraft is a very good tool. We can also do this with AI. It's really exciting. Let's go have a look at how we do this with AI. Okay, so the first thing that we do to make this happen with AI is we use the sgpt command. And then we're going to use, what do you think we're going to, --chat for the sgpt command. Go to the shell, and we're going to discover all the subdomains of google.com using what? So we specify the tool that we're going to use, a dig command. So we do that. Another one we can do is use sublister to gather a list of subdomains on the target organization C council. Now, in this case, we're not specifying an output, so it'll just output it to the terminal. And over here on the right-hand side, you see the output of both of those. So I think that's pretty cool. Let me answer a question. The question I have for you is, why in the world do we even want to get subdomains? And here's an answer for you. Because there's exciting stuff in subdomains. Let's imagine that there's a Fortune 500 company, and this company has the domain cehcompany.com, and they've been around, let's say, since the 80s. They've gone through the internet era. They've gone through the web era. They've gone through web 2.0 and 3.0. And in the process, they have accumulated hundreds, maybe even thousands of subdomains. And very often, a company that large will lose track of some of those subdomains. Just as an example for you, I used to use this quite a lot. They finally got rid of it. But there used to be a subdomain, FTP, File Transfer Protocol, .microsoft.com. In this FTP subdomain, it was an FTP server that had stuff from the 1990s in it, and it was unchanged for decades. And I used to use this for my students to demonstrate the fact that sometimes subdomains got abandoned. Now, Microsoft eventually cleaned it up, I think in 2013 or something like that. But other companies may have subdomains, and we'll see that there are specific types of hacks that you can use against subdomains. So yes, as part of our footprinting efforts, we definitely want to go through and list out the subdomains of any organization. Okay, let's talk about archive.org. This is one of my favorite web apps, one of my favorite websites. What they do is they scrape the entire internet for anything that's there, files, media, for instance, apps, APKs. But one of their specialties, as Obi-Wan would say, are web apps, websites. And so you can go to archive.org and you can type in the name, let's say IBM.com, or maybe if you have a company that's been around for a while and type that in, and then you could scroll through the calendar and find an earlier version of that. Now, that's really cool. I can see the 1997 version of IBM's website, but why would I even want that? Here's the reason. Juicy information, information that an attacker might want. If I go to the IBM.com website right now and I look at it, it's locked down tight with the best developers in the world. It's very difficult to hack it or extract any information from it. But what if I go back 10 years? There might still be relevant information that I can extract from that site by going to archive.org. Right, what else can we do? Job sites. This is so interesting. So what you can do, remember I was talking about Linda from Kevministan and how she's looking for information and LinkedIn, and she is creating a fake Facebook page and so on. Well, how does an attacker like that know how to create a binary, some type of executable that will run on that interior network? Well, I can go to the job site and there's a job posting that says we're looking for a network engineer that is familiar with Windows 11 and PowerShell version whatever, and that can do items or manage a database like, for instance, SQL Server, and they give you the version of SQL Server. They go down a list of things you need for the job, and that is great information for hacking also. So job sites, very good reason to make sure that you are careful with how you post jobs. So Dice, LinkedIn, Glassdoor, etc. And then we have the dark web. So the dark web, if you go to DuckDuckGo right now and you do a search, dark web iceberg. Try that out. DuckDuckGo, dark web iceberg, and then click on images. And then you'll see all these images of icebergs where there's a little teeny bit of the regular internet poking up above the water. And then we have the deep web, which is a large part of that, and then the dark web. The dark web, in it are resources and information, everything from stuff that needs to be hidden to criminal. I mean, if I wanted to order a hitman to go bump off somebody, I might find it in the dark web. If I wanted to order drugs or something like that, for myself, my preference is ibuprofen, but I can get that at the store, so I don't need the dark web for that. But if you want to order illegal drugs, things like that, dark web. And even more than that, if I'm in an organization and, for instance, I'm not sure if some records from my organization have been leaked, I might be able to do dark web research to discover those records and see if they've been leaked, because a lot of leaked records and many other things you can find in the dark web. All right, next thing we're going to look at then is competitive intelligence gathering. You work for an organization, and the organization for which you work has a competitor. And you want to know what they're doing, how they're doing it, what are their latest projects. You can do competitive intelligence gathering, and you can go in and find information about their company, their resources, their dev projects, their expansion plans. You can use this for social engineering and developing competitive projects and find out all kinds of information about them. Next thing we look at then is through other research services. And here's a table. We have a lot of different tables here. If we have a look, let's just zoom in on this a little bit. And we start off with geographical location. I do a lot of traveling, and now and then I'll just go in and zoom in on the geographics, or I have a customer that had a suspicious firewall entry. They'll send it to me and I'll geolocate the IP address. Financial services, maybe even the business profile. There are alerts and tracking that you can do. So you could set up a tracker if the information changes, gather information from groups and blogs, information from public repositories. There is a plethora of resources to gather open source information. Okay, so now we're going to look at social networking sites. So there are a variety of them. And one area I want you to be prepared to research, because there's no way we can get to every site and mention every app that is used for social networking. And remember, there are new social networking sites popping up all the time, and the target of your research may be on an uncommon social networking site. So don't just look at the common top 10 social networking sites. Look for social networking sites off the beaten path if you're dealing with certain types of people or organizations. All right, so LinkedIn. Yes, a lot of us are on LinkedIn. I'm on LinkedIn. You're probably on LinkedIn. And there are some tools that you can use to scrape the LinkedIn API and the app itself, like the Harvester, a very good tool for LinkedIn. You can use that, as you see here, with the Harvester command, and we're going to grab some LinkedIn information. In fact, if you do this, like you see on the screen here, my name will show up, and see if you can find my fake job information that I inserted into there. Fake user information is what it is. So yeah, you won't find the same information on me as everyone else at EC Council. All right, now we do it with AI. So let's have a look at how we do it with AI. And so if we look over here on the far side, we're still using the Harvester. And while we're doing the Harvester, as we see Microsoft, etc., what we're going to do is spider of that site. But over here, we're going to use the Harvester with SGPT, and we're going to bring up that shell again, and we're going to use the Harvester to gather email accounts associated with Microsoft.com. And hey, here's a new thing that we haven't done in the past, which is actually extremely important. Microsoft is huge. So we're going to limit the results to 200, leveraging Baidu. So we're not going to go pull it from Google, pull it from Bing. We're going to use it from Baidu as a data source. And so now we run the command, and sure enough, we get an output from Baidu. Isn't that cool? That's pretty amazing. We're going to see using SGPT and other AI a lot more as we get deeper into the course. Okay, so we've used the Harvester, we've used other resources to get information, but now we're going to drill down into social media presence. So if I found somebody on LinkedIn and then I cross-reference them to Facebook, etc., how do I get information about that entity? See, I use that word again, entity, or the user on the network. Also, using entity these days is actually quite useful because so many things are bots. They're automated programs that do things, and we might need to find information about the bot itself or to reveal that it's a bot. And sometimes you can do that by doing your research. One of the apps we have here is BuzzSumo. Now, I want to pause here, and I'm going to answer a question that you are going to ask yourself when we are in Module 15. And that is, do I have to know every one of these apps and these tools that we're talking about? And the answer is no, but you need to know about them. So for instance, if I ask you a question, if Fred wants to scan a network and pull out the information from port 80 on a host of the network, what tool would he use? And the first answer says BuzzSumo. Am I going to use BuzzSumo? No. The second answer says Nmap. Am I going to use Nmap? Yes, I'm going to use Nmap for that purpose, which we'll get to in the next module. But some of these are tools that are used in a way where you have to choose something else. And because it's so well known, you just might choose that instead. So they're going to try to fool you into clicking or selecting the wrong one sometimes. But other times, especially if an entire page or more is dedicated to the tool, then I would suggest that you go to the lab and make use of that tool so that you understand it, so that if the answer is BuzzSumo, because it says that Fred needs to find the most shared content on a topic, and one of the answers in the exam is BuzzSumo, maybe you'll choose the right one. So that's what we're looking for, shared content in the context of social media. And then we have other tools that will help us find information on social media sites and social media apps. As we see here, we have Sherlock, which will help find information off social media sites. We have Social Searcher to find and search for social media content. And then we can do it with AI. So let's zoom in again here on AI and talk about what we're doing here. In this case, what we're doing is we're using Sherlock. Look at this. Use Sherlock to gather personal information about Sundar Pichai and save the results to recon2.txt. So here we go. Double chat a footprint shell, and we use that specific prompt. And pretty soon, boom, a list of resources. So yep, it's easy to use AI to make use of the tools that we've been talking about. So we are now in learning objective number 5. And here in learning objective number 5, we're going to use different techniques. Specifically, we're going to zoom in on who is footprinting. So who is? Okay, bad joke, but hey, I'm a dad. I can do dad jokes. It's okay. So who is? It's a way to go grab information from internet authorities like ARIN, AFRINIC, RIPENIC, LACNIC, APNIC, in order to find out information about IP addressing, organization, names, etc. So let's just quickly zoom in on this a little bit. I want to make sure that you know for the exam and for your own hacking what each of these are. So if you look at the ARIN is the American Registry for Internet Numbers. And this is if you live in the United States of America, North America, Antarctica, Canada, stuff like that, you will use the ARIN. The next one is AFRINIC, and AFRINIC is the African Network Information Center. So in the continent of Africa, if you need to find domain name information, you'd use AFRINIC. The next one we see here is APNIC. Let's talk about APNIC. That's Asia Pacific, East Oceania, South Asia, Southeast Asia. LACNIC that you see there is Latin America. LACNIC is going to be the Caribbean, Latin America. RIPENIC, the Réseau IP European Network Coordination Center. It's in French, so if I said that wrong, yeah, you can launch a lawsuit or whatever you want. But anyway, that's RIPENIC for the European area. So we have one of these for every one of the different centers around the world where you can get information about domains, subdomains, etc. We also have tools that we could do who is lookups. and find out IP addressing information, user information, registration information. And this is the batch IP converter, and you can pull information about a domain. Now, I will say this, that let's say that there is a domain called kevinkingteachesceh.com. I bet you that domain is open and I could buy it if I wanted. But when you buy a domain, let's say you go to GoDaddy and you purchase a domain, you can get the cheapest level, and that information that you need to fill out to buy the domain will not be locked. So if I did a whois lookup on kevinkingteachesceh.com, it would have my name, email addresses, location, maybe even telephone number, the name of the organization I'm using, etc. But if you go one level more than that, what you can do is lock the domain information. So if you go to do a whois lookup on kevinkingteachesceh.com, it'll just give you general information and not reveal anything about me, email addresses, or anything like that. So the domain that you're looking up might be locked. And in that case, you'll see less information. All right, the next thing we look at then is IP geolocation. And what I want you to do is open up a tab in a browser, type in "what is my IP" and hit enter. And then when you look at that, there'll be either at the top of the page or one of the first selections, there will be an app that will find your current IP address. Now you could take that app and you can put in a different IP address, but either way what it's going to do is geolocate your IP. Another thing you could do is you could do a search on IP location, and that will bring up IP information that'll help you find an app that'll geolocate your IP. This one that you see on the slide is called IP to location, and it gives you information on that. Sometimes I use this as an ad hoc. So for instance, I'm on a customer site, and I'm grabbing information from an edge network, or I find a log that has an IP address that's not geolocated. I just pop it into IP to location, and I find where it's coming from. We are in learning objective number 6. And here in learning objective 6, we're going to be looking at DNS and footprinting with DNS. DNS stands for the Domain Name System, and it's essentially a database that lines up FQDNs, which are fully qualified domain names, like domain name .ceh.com. So that's a fully qualified domain name, and it lines them up with IP addresses. And the cool thing about footprinting with DNS is very often, if you can get deep enough into a system, you can get names of hosts and IP addresses, which can help you really map out the territory very well. So let's have a look at footprinting with DNS. The first thing we want to look at is the fact that we can pull DNS host records, and this tells us the kind of service that we're dealing with in terms of DNS. If you look at this slide right here, you'll see that we have A records and MX records and PTR records, etc. And these are just a few of the more than 50 different record types that you'll find in DNS. Some of the most important being A records, which are host records. So for instance, if you have a laptop or a desktop or a server on a system, it'll have a host records, and then others like CNAME, which are reverse records, and PTR. PTR is very important too, because you'll find those in Active Directory for domain controllers. So having an idea of what each type of record does is extremely helpful. Now, if you look also here, you see that we have tools that we can use that will give us information on those records. And of course, we can bring in AI to help out. Let's have a look at what we do with this particular one here. So what we see is we're using a specific tool. That specific tool is DNS Recon. And so we're going to SGPT, telling it to use DNS Recon against a specific domain. And then what happens is, since we do not give it an output, it will output it just to the terminal. And so instead of opening up DNS Recon and using it ourselves, we can have the large language model AI tool do that for us. Another area that is yet another tool that you can use to help you grab information while you're footprinting is doing a reverse lookup. So when you look at DNS, there's a forward lookup. So imagine this. I'm in a browser. I type in www.certifiedhacker.com. So I've given it an FQDN, and now I'm requesting an IP address for that FQDN. Now, a reverse lookup, I have an IP address, and I want a domain name, an FQDN, or a host name from that. So you could do a reverse lookup. And on the screen here, you'll see that you have one of my favorite tools online of all time, through time, and that is MX Toolbox. MX Toolbox is wonderful because it gives you an entire variety of tools you can use to check on email, to check on domains, check on IP addresses, to check reputation services. It's a very good tool to learn. And then, of course, we have DNS Recon. Learning objective number 7. And in this area, we're going to be looking at email. We're going to be looking at networking and pulling information out of there in order to complete our footprinting. All right, let's have a look beginning with traceroute. Traceroute in Microsoft systems is tracert, tracert, and in Linux it is traceroute. By default, it makes use of the protocol ICMP. Later on, you'll hear me talk about how ICMP is the internet tattletale, because it'll report on everywhere it goes and on everything it touches and let you know what's going on. But there's another issue that we'll talk about when we're looking at countermeasures, is that ICMP is often blocked. So when I'm using traceroute, what it's going to do is it's going to take me through all of the network hops. A hop is when you go through an interface in a router or firewall, something like that. And every time you go through an internet hop, you'll get an indication as to what that device was, whether it be IP address and FQDN or just IP address. However, if ICMP is blocked, we have another opportunity. And as you see here, that is TCP traceroute. So you can use TCP traceroute to get TCP or UDP to report back to you on that system. So if ICMP is blocked at the firewall or somewhere else, hey, maybe TCP will make it through and you can get the report from there. The next thing we look at is making use of AI. Hey, it's all about AI. Let's have a look and see what we're doing here. So as you can see here, we're making use of SGPT's chat function, and we're popping out to the shell and we're telling it, perform network traceroute to discover the routers on the path to where? We specify a target host, and in this case, that target host is www.certifiedhacker.com, and sure enough, right here in the shell, it outputs that information for us. So it does a pretty good job. All right, so what we do, we get back that information and we analyze it. And like I was telling you before, what happens is you see every one of the hops that traceroute goes through as it hits each one of those network interfaces. And in some cases, you will get an FQDN, other cases you get a host name, and in some cases you'll only get an IP address. And there are also cases where you'll get nothing in one hop, but it'll go to the next hop and you'll get information there. As you see the illustration on the bottom, we're going through a router, we're going through a server, we're going through a firewall, and we're identifying the elements on that network as we go. Another area that is very informative is email. Email gives us access to what's called the email header. So in the email header, you get information like the sender and receiver email address, the sender and receiver IP address. We get information on if the email had any issues getting from one point to another. If you see here, we have the servers from which it came, date and time information. So you have a collection of very good information that you can get from email. And later on, we'll look at where you can get this as we get a little bit deeper into the module. All right, now let's have a look at footprinting through social engineering. And as we have an entire module on this, we're not going to do a deep dive into this area. We'll just have a quick look at it. So with social engineering, here's what I tell my students. And to a certain extent, if I'm working with security personnel, I'll say, if you can't figure out how to hack your way into that resource, just ask somebody, right? And that's what we're doing with social engineering. We're using tools to get that information from humans. And what we're doing is sometimes called hacking the wetware. It's hacking what's in between somebody's ears, their mind, their brain. We're pulling that information out. And in the social engineering module, we'll get into some of the features of a specific operating system that makes social engineering very easy. We'll talk about that operating system when we get to that module. But let's go on. We're going to talk next about social engineering in terms of things that we can collect through social media sites. So let's have a look here and see what we have. So if we look at this slide, we'll see that users do a lot of stuff on social media. Yeah, we see they maintain their profile, and we see that they connect with friends, and we see that they share photos and files and so on. So I had a family member, and this family member, there was a girl that he wanted to surprise on her birthday. But in order to surprise her on her birthday, he needed to know where she lived. And he could have asked her, they were good friends, but he didn't want to ask her because that would spoil the surprise. And so he asked me, how do I find out where she lives? And I said, do you have any photos of this friend? And sure enough, there was one photo on her social media site that had a picture of her on her block. And then through OSINT resources, we're able to determine what street she lived on, what her address was, and on that block. And so he was able to very easily surprise her on her birthday. Now, that was a nice, friendly thing, but as you can imagine, people post things on social media that leave them open to all kinds of hacks. For instance, those long lists of where you've been, what you've done, what you like, and what you don't, those are great hacking tools. So if you're trying to hack people, hey, you might be able to spawn one of those. But this table gives you a look at some of the things that people do on social media that are extremely hackable. The next thing we look at is a few areas that we'll get into deeper when we get into social engineering. Eavesdropping, listening in on what somebody's doing, shoulder surfing, watching as they type or click or tap or put in a code or a pin. We also have dumpster diving and looking for the Post-it notes they threw away or the reports they printed out and threw away. And then we get into impersonation, when you fake like you're somebody else, which is getting easier and easier. And again, we'll deep dive that when we get into our social engineering module. Okay, so we are in learning objective number 9. And in this section, we look at automating footprinting tasks using advanced tools and AI. Let's jump on into it. So what we want to do is take some of the drudgery, some of the work out of getting all that information. The first tool that we see here is called Maltego. And Maltego is very nice because as a reconnaissance tool, it helps pull together a lot of different resources, including email addresses and FQDNs and IP addresses and social media information and organizational information. And it makes a little web of interaction so that you can follow what this user is doing. Also on this slide, we have a look at ReconNG, which is very similar, giving us web recon. It gives you a database of interaction, and it's a very good tool to use with AI too. We also have one called FOCA, and here on this slide, you see that it's a tool that finds organizations, fingerprints those organizations, and then we have Subfinder also on this slide, which you can use to find subdomains in relation to organizations. Okay, this one is actually pretty cool. This is called the OSINT framework. And as you can see on the right side of this slide, it creates a network of interactions that is actually easier to put together than Multigo. It's more automated. But we have other tools that you see on the bottom, WhatWeb and ReconDog and many other tools. Now let's integrate this with AI. And so as you see, we have several different AI tools that are on this page. The first one that I want to focus on is called Reconnaissance AI. Reconnaissance AI is a great tool for open source information gathering and automation using an AI backend. We also have OSS Insight. And then if you look at the bottom of the page, you'll see we have Dork GPT. Of course, that makes use of Google Dorks. Chat PDF, which helps you explore PDFs that you find online, and Google Word Sniper, and many others. Now we get to some deeper automation using AI, and this is again using Shell GPT. Let's have a look. So with Shell GPT, we have many different parameters, and when we get into the lab and other parts of the course, I'll talk about some of the parameters besides some of the ones that we've been seeing on the slides and in your courseware, and we'll talk about how to use them. But in this case, we're just using the chat parameter, the shell parameter, as you see double dash shell with FP. And what we're doing here is we're saying to develop a Python script which will accept a domain name www.microsoft.com as input and execute a series of website footprinting commands. And then here's the list. This is really cool. Check it out. DNS lookups, who-is record retrieval, email enumeration, and more to gather information about the target. Now, this little phrase "and more," when you use that for a LLM, large language model, like ChatGPT, that gives it license to use other methodologies. Now, what you find with prompt engineering is very often it won't take advantage of that unless you explicitly tell it to search for other methodologies and use those methodologies. But either way, as you can see here, we have, first of all, the Python script, and then we have an array of output that was completely automated. It's very cool that we can use tools like LLMs, large language models, deep learning, and AI to accomplish things that in some cases would literally take years. But after you hit enter, you get it in just seconds. So now let's explore some countermeasures. And like I said before, often when we get to the countermeasures section of the module, we're going to overview it. And I'm going to give you some keys to countermeasures. And we actually talked about some of these in module number 1. And some of the keys to countermeasures are, number 1, ubiquitous encryption. So as we look through the course, you'll see that a huge number of countermeasures involve encrypting data that's at rest, encrypting data that's in flight, encrypting data that's in use. In fact, when we get into module 20, we'll talk about homomorphic encryption and many other technologies that can help out with this. Then the second thing is ubiquitous IAM. So ubiquitous identity, meaning that for every traffic flow, for every contact, for every file that's open, for every resource, we make sure that we verify the identity of the entity that's doing it, like with OAuth, like I was talking about before, or Active Directory, or even with a simple login. Next thing we look at is ubiquitous hardening. With ubiquitous hardening, what we're doing is we're taking that device, that application, and we're plugging all the holes in it. We're downloading the latest updates. We are closing ports that are not needed. We're getting rid of protocols that we don't want. The next thing that we always find in countermeasures is ubiquitous updating, where we have an update infrastructure that helps us to automate bringing in patches and updating our infrastructure. And then lastly, but certainly there are other things, is ubiquitous training, meaning that we take the people that are involved in any of these things and we train them. So these are some of the things that you'll hear me repeat over and over again. You'll hear me talk about these because they are some of the major countermeasures. But now let's compare what I was talking about, ubiquitous encryption and identity and hardening and updating and training, and let's see if they appear in this list. Come on, let's have a look. So first of all, we see that we want to restrict employees' access to social networking sites for the organization. So that is going to involve a little bit of ubiquitous training. Configure web servers to avoid information leakage. That's going to be hardening. Educate employees. Again, training. You're going to use pseudonyms. If you are somebody like I and you're all over the internet, trying out every resource you can find, trying new LLMs, going into the latest social media sites, adding yourself into projects, then you really need to have pseudonyms that you work under. In fact, I always recommend for especially people who are in cybersecurity that you have completely separate online identities for separate activities. All right, let's look at the next one. Don't reveal critical information from press release, annual reports, etc. That could be training, but that's at the corporate level. Limit the amount of information published on a website. Use footprinting techniques to discover, so we're actually going to hack our own information to see if we can find information about our sites in there. Prevent search engines. We'll talk about that later on. We'll see robots.txt and many other ways to defend against search engine finding our organizational information. All right, we see a few more items that we can do here, including developing and enforcing policies. Remember, everything starts with policy. And then looking at DNS, set up internal and external DNS, or use split DNS. And so this has to do with the way we represent the lookups involving our namespace of our organization. Disable directory listings, make sure that we're training employees about risk, making sure we lock who is, avoid domain level cross-linking. We want to make sure that we keep domain information for that domain, in that domain, and associate with that domain. Oh, there is number 7. That's my ubiquitous encryption, right? We want to encrypt and password protect, and that password protecting is ubiquitous identity. And then we put critical documents offline. Often that's called an air gap. So they're not available online. So for instance, let's say that I have a critical project information, stuff that is top secret. Well, I put that in a system that I turn off and separate from the network. So even if they were able to hack my entire network, they wouldn't be able to touch that system. This is similar to what you do when you have a PKI and you need to protect that root of the PKI. Often you'll take that root, turn it off, and separate it from the network. Let's have a look at the next one. We look at training employees, hiding contact details, disabling geotagging, removing location and travel plans on social media sites. So I remember I was posting the fact that my wife and I were going on a vacation, and I put some quip online about, hey, but don't worry, the kids are home to defend the house, or something like that. So they knew I wasn't just going to leave the house open and be gone. And no, they didn't party while we were gone. Well, let's look at the last few of these. We have the location, travel plans. Yeah, got that. Number 13, turn off geolocation on your mobile device. We'll see that also when we get into mobile devices. And ensure that no critical information is displayed on notice boards or walls. This also is an area of physical security. And that's one thing that I really emphasize with my customers is that I don't care if you're a small or medium business, you also need to have physical security, because somebody can just walk in and take pictures, read things, take devices in, take devices out if you don't have good physical security. So that means in physical security that in public areas, you don't want to write project information, employee information, etc., because someone can walk in off the street or a visitor or whatever and grab that information. So those items I was talking about before that really round out most countermeasures are in play here, and we'll see that with a lot of countermeasures, they're in play for those also. Right out. That brings us then to the end of this module, and we got to look at a fair amount of things in terms of footprinting, including some of the concepts and some of the techniques and some of the tools, everything from using Whois to going to social media sites and doing DNS inquiries and making use of AI tools. So what I want you to do before we go on to the next module, where we're going to look at scanning techniques, is join me in the lab where we're going to go through some of these footprinting techniques. All right, that's it. We'll see you in the next module.